Welcome to Chemical Process Safety. This video is about toxic effect criteria. In the last video, I taught you how to use the Pascal-Gifford model to calculate the concentration, or estimate would be a better word, estimate the concentration of a release hazardous chemical. But what do we do with this information? Remember, one of the things that we might want to determine is whether or not we would recommend that the people who live in that area should evacuate or not. So the main thing we need to know in order to make that consideration is what concentration would we consider as dangerous. So one option, the default answer, you might remember back in industrial hygiene, we talked about the threshold limit value time weighted average. This is not a good value to use to determine evacuation. So remember what this means. TWA means this is the concentration at which a worker could be exposed for their entire working lifetime and be completely fine. So obviously, an accidental release of chemical is not going to be an entire working lifetime. It's going to be very much shorter than that. So the conclusion here is that this is going to be too conservative of a value. So although we want to assume the worst case scenario and err on the side of caution, we can't be recommending evacuation if the threat is not that big of a deal. So for that reason, TLV TWA is out. You could use the STEL, the short-term exposure limit, or the C, the ceiling, if you'd like. These are acceptable, but there are some better options. The first one is ERPGs. These stand for Emergency Response Planning Guidelines. These are issued by the American Industrial Hygiene Association. So there's three levels. There's ERPG1, ERPG2, and ERPG3. They increase in order of, and decrease, I'm sorry, in order of being conservative. So ERPG1, nearly everybody is going to be fine up to an hour. So expect only mild, transient, hazardous health effects, and maybe a bad odor. So something that is potentially bothersome, not necessarily hazardous. ERPG2 is where nearly all individuals could be exposed for 1 hour without experiencing or developing irreversible or other serious effects or symptoms that may impair their ability to take protective action. So this is important, and this obviously depends on what the toxicant is and how it affects the body. But if the toxicant is at a level where it would impair function to where somebody would not be able to evacuate themselves, that is a very hazardous situation. So that's the reasoning behind the language of ERPG2. And then ERPG3 is the least conservative. This is nearly all individuals may be exposed for up to an hour with no life-threatening health effects. So although, again, not life-threatening, it could potentially be very serious. There's a table in the textbook that has these ERPG values for common toxicants. Another one that you might think of is IDLH, the immediately dangerous to life and health. This one honestly makes a lot of sense just from how IDLH sounds like. But we have to remember that people who work in a chemical plant are generally healthy, should we say. They're in good physical shape. They don't have any illnesses or anything like that. Where in contrast, the general public is going to have some people who are potentially older, maybe some people who are ill or disabled citizens, or maybe children without or elderly people. So anyway, there's a more heterogeneous population, and therefore IDLH may be not conservative enough. And again, remember, IDLHs have not been peer-reviewed. And finally, these are the most fun ones to say, the EAGLs and the SPIEGLs, or the EEGLs and SPEGLs. These acronyms stand for Emergency Exposure Guidance Levels and Short-Term Public Emergency Guidance Levels. These ones do consider heterogeneous populations. They also consider different durations of the exposure, and they are well documented in peer-reviewed publications. And you would find these in Table 5.7. Let me get those tables and we'll take a look at them together. So here we are. I've only clipped the very top of both of these tables. We don't need to look at the entire thing to get the idea. This is a table of the ERPGs, again, in Chapter 5 of your textbook. We got ERPG1, ERPG2, and ERPG3 going less conservative as we go up. So if you really want to be safe, go ERPG1, whereas if you want to throw caution to the wind a little bit and be a little bit less conservative, ERPG3. This table is for EEGL, the Emergency Exposure Guidelines. Again, different levels of different times for exposure. 1 hour versus 24 hour are here. So hopefully we have one that overlaps. Here I see acrolein is in both tables. Obviously you see the toxicants are different in the different tables. So you might be forced into using one or the other based on where you have the data in example problems. But what we can see is ERPG1 is 0.05, and that's the same exact. So ERPG1 and the 1 hour EEGL are exactly the same. 24-hour EEGL is going to be, let's see, it's going to be less than that, which makes sense because the longer the exposure, the less the threshold should be. So again, the differences here are that this one takes into account the heterogeneous population, people with lowered immune systems, elderly potentially. And this one is just emergency guidelines. So that'll be it for this video. Hope you enjoyed. See you next time.